By noting the value on the micrometer and changing it, we can count the fringes to find the calibration factor.
Calibrating our Michelson interferometer, we're going to look at our D source on our micrometer reading and count a number of 100 fringes go by. And then looking at our delta M, 100, which is the number of fringes, and our known wavelength of our helium neon laser at 632.8 nanometers, we're going to plug in our delta S value of 0.079, which is how much the micrometer moved, and get a 0.04 calibration factor. So for measuring the wavelength of our green mercury source, we're going to change our distance to our mirror here by changing the micrometer reading until 50 fringes are observed collapsing. We're going to plug that into our wavelength equation for our mercury source here, and we achieve 548.6 nanometers, yielding a 0.5% error. Now, for supposing that we made a mistake in our fringes by 1, running the numbers through here, we achieve a max percent error of 3%. And then looking at to achieve an accuracy of wavelength to about 0.1 nanometers, the number of fringes that would need to be counted would be on the order of 10 to the 4.
So again, we'll change the micrometer in order to see a difference in fringe number, and we will use a sodium source in this experiment instead of the mercury, unlike the last one.
So for the spectral line part of our experiment, we're going to look at a sodium doublet source where there's two wavelengths close to each other. Due to them being so close, we're going to see interference patterns, additional interference patterns, and where the visibility is least, we're going to measure the distance between those to find our spectral line difference, and using that we're going to find a wavelength of our source with a 5% error. So to measure the refractive index of air, we're going to insert this piece into our system where when we pump pressure into it, we're going to change the optical path difference between a mirror and the beam splitter, effectively changing the interference pattern. When 20 fringes go by, we're going to note the difference in pressure and then plug it into our equation to get our corresponding slope, and then use that to find values for our refractive index.
We can see here that the index increases as pressure increases. Here is the slope we calculated using at 20 fringes using the difference in pressure.